Hi, and welcome back to Algebra 1. Our goal for today is to continue working with our polynomial expressions, and more importantly, how we go about adding and subtracting up when we have two or maybe more polynomial expressions. How do we add them up to get a final sum, or how do we subtract them to get a final what's called difference? So at this point from previous learning, I should understand that all our basic vocabulary that goes along with a variable expression still applies. So there are terms, there are going to be like terms, there are going to be constant terms, and there will be coefficients, which are your numbers that are being multiplied with your variables. However, we added in a couple new terms that are specific to our variable expressions that are polynomial expressions. So a leading coefficient is that it is a coefficient of a number or of a letter, right? So if it's your number that's being multiplied with a variable, and it's the one that's out front leading the way once you're in standard form. Remember that standard form is your highest degree goes first, and you work down to your constant term. All your final answers when adding, subtracting, or multiplying, which we'll get to later on, will be to write your final simplified answers in this standard form. So please make sure you understand. I'm looking for my highest exponent on my variable. I'm working down to my constant term. That's how I write my final best possible standard form. Your degree of each term is the highest power on that particular term. So in this problem here, we have a degree of 3, a degree of 2, a degree of 1, and a degree of 0 on the constant term. And what's called the degree of the entire polynomial is which one is the highest, or which one's out front once you put it into standard form. So for this particular example, it has a degree of 3. We also looked at how to properly name these polynomials based off their degree amount and the number of terms that they have. These are key vocabulary words that need to be reviewing. I assume that most of them are new to us, so please make sure that you're taking some time in reviewing that vocabulary. So our goal for today is, if I have two polynomial expressions, can I add them up to get a grand total final sum? And can I subtract them to get a grand total final difference? And more specifically, we are going to use what's called the horizontal method. Right, we have two ways of adding and subtracting polynomials. One that's horizontal, meaning across our paper this way. And a second one, which is vertical, which goes up and down like this, like how we would have done adding, subtracting in elementary school. We're going to look at both methods, starting with our horizontal method. The reason why we're starting with our horizontal method is it's identical to our simplifying variable expressions method, where all I have to do is distribute and combine my like terms. Now, the only catch here is when I go to combine my like terms, I need to think about standard form order, so be careful. So our steps for today, using what's called the horizontal method to add or subtract polynomial expressions. Step 3 up here where it says move like terms next to each other. It's not a required step, so I'll show you one example where we do that, and I'll show you other examples where we do not, because we did not do that when we were simplifying, but it might help you to ensure that you end up with that standard form order. So the first thing you want to do is, there's going to be no numbers outside of our parentheses because we're going to have two polynomial expressions, right? One big polynomial plus another, or one big polynomial minus another. So you want to put ones on the outside of your polynomial expressions, or outside the parentheses. So your first step will be to distribute. You'll be either distributing a positive one or a negative one, so be careful with your sign. Once you distribute and you have individual terms, you want to look for your like terms and add them up or combine them, but in the special order of standard form. So that's why that step 3 might be helpful. It just gets you organized into that. What's my highest degree working down to my constant term? So for example number 1, I'll go ahead and show you that putting them next to each other step. And then from there on out, I'm going to skip it, but you are always allowed to include it. All right, so we have the linear binomial x minus 5, and we're adding to it the linear binomial x plus 15. Again, there's nothing on the outside here, so we want to think, when we say add them up horizontally, it's the same as if we just said simplify here. So we're going to put a 1 here that's going to get distributed to x and minus 5, and we're going to put a 1 here that's going to get distributed to x and 15. Now, these are all positive ones for this on the since it's an add problem, so our ones on the outside are positive. So when we distribute or share, it's not going to change anything about what's originally there as far as its value, but it's going to accomplish that first task of we have to remove the parentheses to be able to combine our like terms. So 1 times x is still a 1x, 1 times -5 is still a -5, 1 times x again is still a 1x, and then 1 times 15 is still a +15. Now, for this problem, I'm going to show you that optional step, and then you can kind of pick and choose from this point on if you need it or not. We want to rearrange in standard form. Our highest degree here is a 1. This is a linear. It'll be a linear binomial when we're done adding. So our x's go first. So we're going to put our 1x and our 1x together. Right? Those are going to combine to give us something. And then our -5 and our +15, right? Those are going to go together. So it might, again, be helpful to put your terms that are going to combine next to each other and in that special order of standard form. All right, 1x plus 1x would give us a 2x. A -5 plus 15 would give us a +10. And our final, what's called sum in this case, would be 2x plus 10. Now, this step here is optional. You must show this step. You must show this step. So just make sure that you're showing at least the required work. All right, number 2, we want to calculate the sum horizontally. When I add up these problems horizontally, it's the same as if it just says simplify. I'm going to distribute, and I'm going to combine like terms in standard form. So I'm putting in my 1 here. It's getting shared to 4x squared and 16. So 1 times 4x squared is still just a 4x squared, and 1 times 16 is still a +16. All right, same thing here. We're going to put it in our 1. It's going to get distributed here to 3x minus 7x squared and -4. So plus 3x minus a 7x squared and a -4. Again, you have an option here to put your not required move them together steps. So I'll go ahead and do that on one more here. We want our highest degree. This x squared is our degree of this polynomial. This is a quadratic. So we want the x squareds first, then our x to the first, and then our constant terms. So 4x squared minus 7x squared would go first, right? That would be the first thing in our simplified thing. Then our x to the first, so plus our 3x here. And then our constant terms, right? So this is just going to stay as 3x, it's by itself. And then plus 16 minus 4, right? That's going to combine. And we're going to end up with 3 terms here and a degree of 2. So we're going to end up with what's called a quadratic trinomial. All right, so 4 minus 7 would just give us a -3x squared. Plus our 3x here. That didn't have a like term. And then 16 minus 4 would just give us a plus 12. So final sum in this case, a quadratic trinomial of -3x squared plus 3x plus 12. Again, I must show this step. I must show this step. And this step here in between is if I think I need it to help me get that standard form order. All right, so the last 2 here, I'm not going to show you that optional step, just to show you that that option exists. And we want to calculate the difference horizontally. Remember, calculating a sum or difference horizontally is just as if the direction said simplify. We're going to distribute, and we're going to combine like terms. All right, so a +1 here to 6x to the third minus 9x plus 2. So 1 times 6x to the third is still 6x to the third. 1 times -9x is still -9x. And 1 times 2 is still a +2. Now, here's where you need to be careful, because remember, this is a -1. That whole thing is going to get shared or distributed. So it's a -1 times 5x squared. So minus 5x squared. This is a negative here also. A negative times a negative here is going to give you a positive. So we're going to have plus 1x to the third. And then this is a -7. So a negative times a negative again will be a +7. And I promise the biggest place where these problems aren't that tricky, but the biggest place where I'll see mistakes is with our signs, when we have to distribute a -1. So be careful. All right, we want to combine our like terms in standard form order. So I'm going to skip that optional step and just show you that we could go straight to what our standard form would be. So our highest degree here is an x to the third, right? This would be a cubic. So I'm going to take our 6x to the third and our 1x to the third. We want to start with those first. So 6 plus 1 would give us a total of 7x to the third. All right, I might want to lightly just say, all right, I've eliminated those. And now I want to go to my x squareds, right? We're working down. 3, 2, 1 constant term. So x squared terms would come next. So minus 5x squared. It doesn't have a like term, so it's just going to stay as minus 5x squared. Then we want to go to our x to the first, which is just our minus 9x. And then our constant term, 2 plus 7, which would give us plus 9. Good final, cubic quadrinomial. 7x to the third minus 5x squared minus 9x plus 9. All right, let's try it. One last one. All right, we want to get our final difference here, which is just a fancy way of saying do subtraction. And we want to use our horizontal method. That is the same as if the directions just simply said simplify. So we want to distribute and combine like terms. So positive 1 here is going to these. And be careful here, this is a negative 1 that's going to get shared back here. So negative 2x to the third, 5x squared, minus 1x, and plus 8 aren't changing because we're multiplying all of those by a positive 1. All right, multiplying back here by a negative 1. Anytime you take a value and you multiply it by negative 1, you're going to get the opposite of the original number. So negative times negative here would be now a positive 2x to the third. A negative times a positive here would be now a negative 3x or minus 3x. A negative times a negative here would again give us our opposite of plus 4. All right, now we're ready to start adding things up or combining our like terms and in standard form order. So this again has a degree of 3, so we want to start there first. All right, so negative 2x to the third plus 2x to the third. Negative 2 plus 2 are opposite, so that's actually going to give you 0. So the easiest thing to do would just be leave off the x to the third. There is no x to the third, right? There is 0 x to the third. Now, could you put a 0 x to the third here for a minute? Yes, but it's not necessary because 0 times anything, it would just go away. It would be a value of nothing or 0. All right, so plus 5x squared. I'm going to go ahead and just erase this because on my final most simplified version, whoops, give me the eraser. And the final most simplified version, we would eliminate that anyway. So I'm going to go ahead and eliminate it right away. And I'm going to go straight to my x squareds. In this case, all we have is a 5x to the second. All right, let's go to our x to the first. We have this minus 1x, this minus 3x. So negative 1 minus 3 would give us a minus 4x. These are now gone. And then 8 plus 4 would give us a plus 12. And what looked like a cubic is actually a quadratic trinomial when we're completely done simplifying. Good final, 5x squared minus 4x plus 12. All right, so here's what you need to do. You're going to grab a piece of paper or work in a notebook. This is activity number 2. You're going to complete these 5 problems. When you're done, you're going to take photographs of your steps of work and submit them to Schoology. All right, hit pause here so that you have your problems there in front of you, and as soon as you're done, submit them. If you are not learning through the video, obviously you will go through them face to face. All right, see you guys later.